Now, in solving problems of stoichiometry or chemical arithmetic, we have to make use of a concept, the concept of equivalent weight. It's quite a useful concept. Nowadays, we don't stress it very much. Nevertheless, in problem solving, it is of very great use. We shall now see what it is. How do we define the equivalent weight of an element? Suppose we have nitrogen. How do we define the equivalent weight of nitrogen? Obviously, we will have to consider a compound of nitrogen. For an element, we define the equivalent weight is equal to the atomic weight divided by the valency. For nitrogen, the atomic weight is 14. In the ammonia molecule, which is NH3, the valency of nitrogen is 3. Therefore, the equivalent weight is 14 divided by 3. It is obvious now that it depends upon what compound we consider. The atomic weight is a constant, but in different compounds the valency will be different. I will give another example. Take sulfur. Sulfur can form different compounds. One compound is hydrogen sulfide, H2S. Another compound is sulfur dioxide, SO2. And a third compound is SO3. Now look at the atomic weight of sulfur is 32. But here sulfur is divalent. So you have to divide the atomic weight by valency 2. Here sulfur is tetravalent. Therefore, the atomic weight has to be divided by 4. And here the valency is 6. Therefore, the atomic weight 32 has to be divided by 6. Quite obviously, depending upon the compound, the equivalent weight is variable. Similarly, as another example, take ferrous oxide FeO and Fe2O3. Here the valency of iron is 2, so you have to divide the atomic weight by 2. Here the valency is 3, so the atomic weight has to be divided by 3. I am giving this example again to emphasize the fact that it depends, what we define as the equivalent weight depends upon the particular compound that we are considering. Similarly, we have equivalent weight of acids, equivalent weight of bases. The equivalent weight of hydrochloric acid HCl is molecular weight by 1, because one molecule contains one replaceable hydrogen HCl, only one H you see. Therefore, the molecular weight has to be divided by 1, because 1 is the number of replaceable hydrogen atoms. For sulfuric acid, it is H2SO4. There are 2 replaceable hydrogen atoms. Therefore, the molecular weight has to be divided by 2. And for bases, always, what is the equivalent weight of base? What is the equivalent weight of sodium hydroxide? It is that weight which will react with one equivalent of acid. You know that HCl reacts with NaOH. HCl is one equivalent. Therefore, NaOH is one equivalent. That is, the molecular weight of NaOH is its own equivalent weight. That is the way it is defined. So far as reactions are concerned involving oxidation and reduction, very often there is a change of valency that is taken into consideration. For example, permanganate KMnO4 functions as an oxidizing agent in dilute sulfuric acid medium. And when it functions as an oxidizing agent, it ultimately becomes manganese ion. Now, what happens is, here in permanganate, the valency, so to speak, or the oxidation number, the oxidation state, the valency for manganese is 7. Whereas here, as you obviously see, it is 2. So, there is a change from 7 to 2, 5 units. Therefore, we divide the molecular weight of permanganate by change of valency, which is 5. So, in such reactions, it is the change of valency that has to be utilized in actual calculations. There is one basic principle throughout which helps us to solve similar problems in chemical arithmetic, and that basic principle is one equivalent of any substance A will always react with only one equivalent of another substance B. We don't care now about the molecular weight. One equivalent always will react with one equivalent, and that basic principle is to be utilized in all problem solving in chemical arithmetic or stoichiometry.